welcome back to my channel Java with Ali, and I am Ali, and today we're going to summarize concurrency and hopefully then move on to the next topic next weekend. So, introduction then, I've changed a little bit about the presentation today. I'm going to do a presentation and not just talk through it, so hopefully this will be good. I'd appreciate your feedback. Please like, share and subscribe so I know to make more. Okay, so the introduction then. Two tasks are operating concurrently are both making progress at the same time. Two tasks operating in parallel are executing simultaneously, and that is parallelism, because parallelism is a subset of concurrency. Concurrency in Java is in the language and the APIs being application programming interface. Java can have multiple threads of execution where each thread has its own method call stack. If you're unsure about method call stack, it's part of the data structure stacks video that I did, and you can check that out in the data structures playlist. It's quite a funny video actually. It's one of my first ones. And the program counter as well, so allowing it to execute concurrently with other threads, and this is called multi-threading. So then we have thread life and states, and I think I used the analogy of having multiple people on treadmills as they run on the treadmill. So when they're on the treadmill, they're in runnable state. When they're off the treadmill and when they go for a nap because they're so tired, they're in a sleeping state. But they're only on a sleeping state for a short period of time, for a timed amount, so 20 minutes, and then they're back on the treadmill again. If they're on the treadmill and it's blocked, that means they're standing on the treadmill is now blocked, no other runner can go on that treadmill, but their two legs are on the side. That is now a blocked state. Then you have terminated. I'm now finished my run, I'm going home. That is when the treadmill is now free and the person is gone. So there are your thread, life and states in analogy form. Then we have thread, life and states. Again, where when the highest priority thread enters the ready state, so, okay, I'm ready. The operating system generally preempts the current running thread. So depending on the operating system, and this is why hardware is more important when it comes to running different threads, higher priority threads could postpone or potentially indefinitely push it off to the side and say, you're a lower priority task, I don't want to go near you. So then we spoke about and we did examples on the Executor Framework, which is quite an interesting framework because it uses multiple things within the Java util.concurrency package. Correct me if I'm wrong. So a runnable object represents a task that can execute concurrently with other tasks. So we have a runnable object, so we've got multiple people standing on their treadmills all together. They're acting as a team. They can't go with one. They're all related. So the interface runnable declares method run, and we saw this in the IDE and Eclipse when we could generate, when you use the runnable interface and you say generate the methods associated with it, that means you're generating run, which we saw in the previous video. So a program will not terminate until its last thread completes execution. Program's not done because everybody, if you think of the whole gym as being the program, it doesn't shut down until everybody's gone. So you cannot predict the order in which the threads will be scheduled, even if the order in which they were created and started. So use the executor interface to manage runnable objects. Okay, are we good so far? Let's go back to this again. A new thread begins with a new state. Then we have runnable waiting state. You're waiting for another thread to perform a task. Are you done yet? Are you finished on that machine? Sleeping is, okay, I'm now sleeping on a chair, waiting for things, waiting for a treadmill to become free. I have a set period of time until I can hop back up on that treadmill again. A runnable state thread transitions to a blocked state. Somebody's blocking the treadmill. They're not running on it. They're just, putting their legs on the two sides. They're blocking the treadmill, but they're not running. And the thread must temporarily wait until that task completes. So a runnable thread enters terminated state when it successfully completes its task or otherwise terminates. Okay, good so far. Executor framework then. An executor typically creates and manages the group of threads called a thread pool. And we spoke a bit about printer pools and task pools and stuff. Anyway, we've got a thread pool. Executors can reuse existing threads and improve performance by optimizing the number of threads to ensure that the processor stays busy. We want it to stay busy. Why? So we come back to it again. Executor execution method receives a runnable and assigns it to an available thread in a thread pool. So it receives a runnable. It's like, okay, you're runnable. Okay, you're going to be here now in this pool of treadmills available to you. You're going to pick one and go for it. If none, then if there are none, then it creates a new thread or waits for one to become available. The interface executor thread, the interface executor service even, extends executor and declares other methods managing the lifecycle of executor. So the service extends executor and then manages executor. We'll go through that again. The interface executor service extends executor and declares other things to manage the lifecycle of executor. That's like the relationship manager or the trainer in the gym. So you don't have the owner of the gym coming to say you hop on this, we have the trainer, which is the interface. So there's one person between it, and the trainer has different tasks and different methods to give to each of these people on the treadmills. Executor framework then, executor's new cached thread pool returns an executor service that creates a new thread or multiple threads if no existing threads are available within that to use. So the executor, then the executor service method, execute method executes runnable sometime in the future, and the method returns immediately for each invocation. The program does not wait for each task to finish. No. Why would we wait? Why would we wait? So the executor service method shutdown notifies the executor service to stop accepting new tasks and continues executing existing tasks and terminates when those are complete. So again, this when I have exe here, it's the execute method. Okay. Thread synchronization. I spell it with an S because I come from Ireland, but in the Java program, it's spelled with a Z. Remember that. This coordinates access to shared mutable data by multiple concurrent threads. What do we mean by mutable? Mutable being we can edit it. By synchronized threads ensure that each thread accessing a shared object excludes all other objects from doing so simultaneously, and that is called mutual exclusion. So if you're an electronic engineer, you've probably heard the terms mutual exclusion before, or if you did biology in school, also mutual exclusion. Java has inbuilt monitors and monitor locks for every object. In real life, if you have worked maybe as a data analyst or a business analyst of some sort and you're working with databases, maybe a couple of years ago now, I don't think they do it anymore, but with Access databases, you had to lock them and unlock them for one person to edit it at a time. So actually, it's still available within other programs as well. There are other programs out there, shared document across companies that they use that still do this, where you have to lock the document before so that nobody else in the organization can edit it, and vice versa. So that ensures mutual exclusion. The method should be placed in synchronized block using the synchronized keyword. A synchronized instance method must acquire a lock on the object that is used to call the method. Similarly, a static synchronized method must require a lock on the class object that represents the class in which the method is declared. A class object is the execution time representation of a class that the JVM, Java Virtual Machine, has loaded into memory. Are you with me so far? Executor service method await terminates forces. Await termination should be all one word. Await termination forces a program to wait for threads to terminate. It returns control to the caller, either when all tasks executing in the executor service complete or when a timeout elapses. And that is the end of the presentation. I just want to check if you like the presentation style. I will continue to do so. If so, please like, share, and subscribe. I'm going to continue just talking through the rest of the summary. It depends on which you prefer. If we would also do maybe presentation alongside the program, might be better. Might try that the next one. So we also had examples from producer consumer without synchronization. Without synchronization. So a producer thread generates data and places it in a shared object called a buffer, and a consumer reads the data from the buffer. So we've got consumer reads, producer produces. Operations on buffer data shared by the producer and consumer should proceed only if the buffer is in the correct state. So the buffer can be full or it can be empty. So if it's not full, or it can have stuff in it, but anyway, if it's not full, the producer may produce. If the buffer is empty, the consumer may consume. It's not empty even. It's not empty. If the buffer is full when the producer attempts to write, then obviously bad things are going to happen. So the producer must wait until there's space. So there has to be space for things to go when you produce stuff. So you produce the stuff, box is full, have to wait until the consumer reads all this data. So if you picture two people, one person is reading a book, let's say, and then the other person is creating all these books, and they're in a box between them. So one person is writing all the books and they're placing it in this box, and the other person is collecting the books from a box and they're reading it. So the consumer needs to read more. So there's space for the producer to put stuff back in the box, basically. So if the buffer is empty or the previous value is already read, the consumer must wait for new data to become available. Okay. Then we went on to array blocking queue. Array blocking queue is also part of java.util.concurrency. And that implements the blocking queue interface. An array blocking queue can implement a shared buffer in the producer-consumer relationship. And then we have the method put. So I'm going to put stuff at the end of the queue, and then I'm going to also remove it or put stuff, place stuff at the end of the blocking queue, waiting if the queue is full. And then we have method take. So I'm going to take it, I'm going to remove it from the head. So I'm going to take from the top and put at the bottom of the queue. So array blocking queue, again, it's data structures, so queues. Array blocking queue stores shared mutable data in an array that's sized with an argument passed to the constructor, and it is it's an array. If you think of arrays are fixed length, so we have array blocking queue is fixed in size once it's created. We also spoke a little bit about some other parts where we had sort and parallel sort as well. So we had class instant, static method now it gets the current time. Then we had, so if several threads are trying to call the method lock on the same lock object at the same time, only one thread can obtain that lock. So then we had method calls to unlock as well, and then we have like condition runnable, signal all, etc. So we're going to end that now today as we are now finished. Concurrency as the summary. This is again the intermediate part of it. There will be another playlist after this for advanced. And then I hope to progress onto other topics as well. If you like the video, please like, share, and subscribe. And stay safe, and I will see you again in the next video. Okay, thanks, bye.